So in this lecture, we're going to talk about integrals of symmetric functions. There's going to be two parts, and so in this one, we're going to talk about something called even functions. Okay, so we're going to suppose that f is going to be a continuous function on this interval minus a to a. So suppose that f is continuous on this interval, which is like minus a to a. Okay, then we have that if f is even, so, and then I can show you a little what I mean by that. So f is even. So what does it mean to be an even function? It's going to mean that if I take, okay, so if I take f and I evaluate it at minus x, then what's going to happen is I'm going to get the exact same thing as if I evaluated it at x, with, x squared being a good example, as I'll highlight kind of in a moment. So we get the same output. So this is kind of how to think of it, is we get the same output, right, if input any x and minus x. Okay, so if we're in this circumstance, then we're going to have we're going to know that if I take the integral from minus a to a, of f of x dx, that this is going to equal 2 times the integral if I went from 0 to a of f of x dx. Okay, so this is like having, here's kind of the picture. And right, it's okay to replace, maybe my inputs are thetas instead of x. These are variables. That kind of thing shouldn't confuse us too much in life. So now I'm going to take this function cosine theta. I have a lot of troubles drawing this symmetrically. So this function is y equals cosine of theta. And I'm standing in front of it, so now you can see it though. Okay, and let's look at, so if I looked at the integral from maybe minus 3 pi fourths. So notice that I'm requiring that this is just minus of that, okay? And if I took this for cosine theta d theta, that this would equal the integral from 0 to 3 pi fourths of cosine theta d theta. Okay, so if you look at that, so what's actually going on here? By the way, so we can put this in this picture just to kind of give you a sense of where things are. This is like pi halves. This is pi. This is 0. This is minus pi halves. Oh, wait. This is pi halves. This is not. This is 3 pi halves. This is minus 3 pi halves. This is pi here. And this is minus pi. Okay, so what we're looking at is a picture from, right, so where is 3 pi fourths? So it should be kind of right between here. So we're looking at what happens between minus 3 pi fourths and 3 pi fourths. And then if I kind of went through And I said, okay, well, I'll just look at on this side, this picture, right? Then this would give me the same area as if I did the same thing on this side. Right? So these two areas are the same. Okay? So even these two signed areas. So I'll even kind of, these two signed areas are the same. So by these, I mean this one and the pink one. Right? This is what happens. So another way to think of this is this is actually symmetry across the y-axis, right? This is symmetry across the y-axis, and when you have symmetry across the y-axis, and this is minus of this, the picture is going to look exactly the same. So you're going to get exactly the same area. Okay? And so I want to kind of give you, so why do we, this might help you remember that these are even functions. So what's actually a kind of our other favorite example of this? So more favorite even function examples. Trying to make sure I don't run off the side of the board. That's why I keep on looking up at you. You're like, why should you keep on looking at me? Okay, so here we go. Okay, so we actually get all of these functions. F of x equals x to the k, where k is even. Oops, it's supposed to be a k. So this is f of x equals x to the k, where k is even. Right? And these all actually look the same, more or less. It's just how steep they are. So for example, what would be an example of an even? So if I took like, you might look at this and say, oh, this looks like y equals x squared. It also actually looks like y equals x to the 6th. Okay. So here I'm labeling these x and y. Okay, and then we're going to have, so if I went from some kind of minus a to a here, and I looked at these areas, we would again get the same area, right? Because you can kind of see that if I'm symmetric across the y-axis, that this area and this area are going to be the same. Okay, so this could be y equals x to the 6th, or, and this picture would actually look the same, that this could be x squared, or x to the 4th, or I already said x to the 6th, so maybe x to the 8th, right? Or x to the 1002. It doesn't matter. As long as it's an even number, the picture actually looks kind of the same, and you're going to get, these are all even functions, and you're going to get exactly the same thing, which kind of gives you a shortcut in computing. In particular, it might be somehow a little easier to compute it with 0 or something like that. So this can actually kind of be useful. I also kind of just wanted to show you because it gives you a feel for a new kind of function. Okay? So great. So I went through even functions in this one. The next one I'll go through odd functions. I hope that made a little bit of sense, and I will see you in the next lecture where we'll talk about odd functions.